Okay, so I just wanted to do some more work on that example that I went through in the first video. We got to this point where we had a small program where you could type in a 4-digit binary number, press convert, and it would tell you what the decimal equivalent was. So here's an example of a binary number. If you press convert, we get 10, which is that number in decimal. If I click that again, I get 14. If I say turn digit 1 to 0, I get 12. So we got to the point where it was working, and we got to the point where I could handle parsing errors. So if I type in some rubbish into one of the boxes and click convert, I'm asked to enter valid bits in the text boxes, please. Okay, what we didn't do though was deal with cases where there are non-binary numbers in the text boxes which are still valid integers. So the program currently only checks for valid integers and doesn't check to see whether they belong, like whether they're either 1 or 0. So if I click convert with these inputs, I get some number calculated, but that obviously doesn't make sense since these numbers are not bits. Okay, so let's think about how we can improve this program so it does better error checking. Well, last time I talked briefly about using an OK flag to declare or to specify that the input is OK. I showed you quickly how to do that, but then I changed the program so that most of the input processing and output occurs within this try-catch block. So what I'm going to do is go back to the way that I had it before, and if we try to remember that, I had a boolean variable, okay, and I set that by default to false. So we could give it a more descriptive name. We could say input, call it input is okay, but I'll just say okay. And then we have the try block, which is going to process the input, and then I'll set OK equals true at the end. Okay, so only if the program gets through to this line here, which means it successfully passed all of these, then OK is set to true. So let's go and move that catch block up. So we want to remove that, cut that out, and we want to place that here, and then let's fix the indentation everywhere else. Okay, here I'm fixing the indentation, just bear with me for a minute, won't take too long. What have we got here? I think we've got one, yep, so that's all fine. What we've got down here is just a warning, so there's no errors here. The warning's just that OK is assigned but never used. Okay, so what the program is going to do is set OK to false initially, try to parse the input. If we get to this point, which means success, then we set OK to true. Otherwise, OK will still be false. Okay, does everyone agree with that? Which means we can then say if OK, then do all the rest. So the idea here is if the input is are all valid integers, we'll do this part of the program, the processing and the output, and if they're not valid integers, we won't basically do any of this stuff because OK will be false. Let's double check that that works. 0, 0, 0, that all works, still works when I put in bits. If I put in a letter here, no, we get a failure. if I put in a letter, some rubbish here, I press convert, get an error. Okay, so let's well, we haven't actually changed what the program does yet. We can still type in numbers which are not ones or zeros. We can see we get 88, so we haven't actually achieved what I set out to achieve at the start of the video, so let's now do that. So the idea is, when we get to this point, as I said, digit 3, digit 2, digit 1 and digit 0 will all be valid integers. So how can we ensure that these three numbers are all ones or zeros? Well, we want to do it obviously before we calculate the result, so before we get to this point. So where are we going to do it? Well, we could do it inside this if statement, or we could do it outside the if statement. So I think what I'm going to do is do it outside the if statement. So we can say if OK. So that's saying if the four numbers are valid integers, then we simply check to see whether they are okay. So we're going to need more if statements. So if digit, let's start with digit 3 equals 0, or digit 3 equals 1. Okay, that's the case where well, let's just change that, say does not equal. This makes more sense. So if digit 3 is not a valid bit, so it's not a 0 or a 1, then set OK equal to false. Okay, does that make sense? So OK initially is true if we get to this point. So if these four digits here are valid integers, then when we get to that, if digit 3 is not 0 and is not 1, which means it must be something else, like minus 500 or 3 or 4, then we set OK to false. Okay, and we do that again for each of the other digits. So we do digit 2, and we do digit 1, and we do digit 0. So the result of this is going to be that OK is going to get set to false whenever the digits are valid integers, but they are not a 0 or a 1. And since OK may get set to false here, if one of the digits is invalid, then this won't happen. Okay, so let's run that and test the default case first, test some valid cases. Yep, that's still working. Test the case where we've got rubbish in one of the boxes. Yep, we get that valid bits error. And now let's test the case where we've got an integer, and we can see that nothing's happened. Okay, so OK has become false on that second block of code, that second checking part, but it's not showing. Yeah, the output's not displaying. So the output's not being updated really, it's just staying the same. Let's make it print out a message. So if not OK, then we're just going to copy and paste that. Yeah, please enter valid bits in the message box. Now at this point we've got two message boxes. We've got one up here and we've got one up here, but we already they're both saying the same, displaying the same message. We don't really need to have two of them here. So what I'm going to do is simply delete that second one, and so the catch here is going to have nothing in it. And it's an interesting question about whether I can just delete all of this. Let's try that. And it seemed, no, we need to have so you can see down here we need to have a catch. So I'm just going to have a catch with nothing in it. And I'm going to see if this program works. So let's test the different cases. So we've got the default case. It seems to work. This is where the input is all valid. So we can see that we're getting correct calculations there. We've got the rubbish input case where we just have garbage typed into one of the text boxes. We get an error message. And finally we have the correct integer input case, but they're not bits. And we get the box there. All right. And that about is the end, about as much as of this program as I wanted to talk about. If we put back the valid inputs, it then works properly and updates the output correctly. So I could do a lot more work on this. I could tidy up this text box here and make the output a bit prettier. But I'm not going to. The aim was simply to go over how we might write a program that's got several inputs where some of them are integers that need to be parsed, and how we might deal with parsing errors, and also how we might deal with errors where the user has, or where the input is parsed correctly but the inputs are still invalid because they're the wrong numbers, so they're not a 0 or a 1. Okay, and we've gone through that. We've used OK as a boolean variable called OK as a flag, and I've showed you how to generate the output in a multi-line text box. So I think that's enough for this example. I'll post another recording soon where we do some more examples with if statements.